Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur. We are in week 10 and session 2 and we were discussing text mining, natural language processing and basically tokenization. So, as I told in the last video, in the last slide for the last video, that tokenization severely limits the context. So, that is true. What is tokenization? That means that I first from the text data, if you see here from the text data, we convert the text to token sets, but before doing that I actually remove various kinds of stop words, the punctuations, and then after removing all of these and probably sometimes stemming also, and after removing all of these things we convert each unique word to a particular token. And now what we do, we actually can find out which token is most frequent, which token is least frequent and so on. Now, tokens has a term called term frequency and inverted document frequency, which tells me that which token, which word is more important. Let us just assume that I am analyzing customer reviews on hotels. Can you tell me, when I am analyzing customer reviews of hotels and there are, let us say, 10,000 reviews, each row is one review. I have a Excel file where review 1, review 2, review 3, review 4, that is the serial number, then the text of the reviews are there. And with those text of the reviews, I removed the stop words, removed this, that, etc., etc. After that, can you tell me that which word in a review of hotels will be most frequent, which word will be most used? Just think about it. So, if you do that, if you sometime do that, and we will do that later probably, the word which will be most frequent is hotel, the hotel, 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 this word, because we are reviewing hotels. So, everybody will say that this hotel is good, this hotel is this hotel is that. So, the word hotel will be the most common one. The question is that whether this word is meaningful enough or not. How I can say that some word is meaningful in creating information and some word is not meaningful in creating information. So, that is where this TF-IDF context comes in. Just think about TF-IDF. So, if there is my review 1, review 2, review 3, review 4, review 5 and review 6, let us say, and some text is there. This is one text, text 2, text 3, text 4, text 5, text 6. If a word occurs most amount of time, the more a word occurs within a text, the more important the word is. That makes sense. The more a word occurs, the more important that particular word is. Just 1 minute. On the other hand, if the word is actually occurring here also, here also, here also, here also, here also, here also, then that particular word is less important. So, the more a word occurs in different text, the less it is important. So, this is something that we try to make sure. So, for example, when somebody says about a particular term quite a lot, in a particular text, that means within that text that particular term is important. But if I say that term every time I speak, so I remember in our childhood, I should not say probably, in our childhood there was a teacher who used to say some word, let us say got it, got it, got it. This got it he used to say a lot when he is teaching. So, let us say he is teaching that Akbar did this, that and etc., and then probably Ashok did this, got it, okay, and then this one, XYZ, then got it. So, this got it term was his problem of speech probably. He used to use this particular term quite a lot. Now, in every term if this got it comes in, then he is actually not, this got it has no meaning. That means, in all the documents that he is creating, the speech documents that he is creating, this got it term is common. So, the more a word occurs in different text, the less is its important. That particular got it does not meaning that he is actually is more concerned about whether you have understood or not. That is his way of teaching, and saying got it is something that is very common for him. On the other hand, within a text, let us say he is not commonly says got it, but in a particular type of text he says got it a lot. Let us say while he is teaching, only then he says got it a lot. In other kind of conversations he do not say got it. So, if then that particular got it is more concerned about, more important in this particular text. So, similarly, the words which are more commonly occurring in one particular document, here document means this is one document. So, one particular document that is most important to that document. So, that is term frequency. Inverse document frequency means the more it occurs in all various kinds of documents, the less it is important. That is why it is inverse to document frequency. So, this is called, this is called term frequency, and this one is called document frequency. So, that is what is also something that we are trying to discuss. What is a term frequency? A term frequency TFIJ is a measure of importance of term I in document J. So, that is what a term frequency is. It is a measure of importance of term I in document J. So, inverse document frequency is a measure of the general importance of the term. So, that is something that also is meaningful. So, what is term frequency? Term frequency is the measure of importance of term I in document J, and then inverse document frequency is the measure of general importance of this particular term. So, high term frequency for apple means that apple is an important word in this specific document, but high document frequency for apple given a particular set of document means that apples is not at all that important, it is occurring everywhere. So, since it is in all the documents, this is a topic about probably apples only, and that is why apple is coming up. Nobody is focusing on apple a lot, it is just common. So, that is what term frequency and inverse document frequency is. So, inverse document frequency has been measured in like this, log of mod of d by dj, where dj is occurring within d. So, the log of count, how many documents are there, that comes in the numerator, and the denominator is the number of documents in the master collection divided by the number of those documents that contains the term. Fair enough. So, that is, and TF and IDF is nothing but the multiplication of that TF of ith product in jth document into the total IDF is the importance of that particular term within that document. So, a background collection of documents has to be given and a specific ordered list of terms is given. We can encode any document as a vector of TF IDF numbers, where ith entry is the vector for document J is. So, that is something that we can do. So, let me just show you an example what I am talking about. Let it open. Okay. What this TF-IDF is? Let me just make it bigger. So, let us say I have these 4 terms. I eat fish and vegetables, fish are pets, my kitten eats fish, kitten is a lovable pet. These 4 lines are there. So, each of this line is one document. So, first job is removing full stop, you can remove other things also. So, I eat fish and vegetables, fish are pets, my kitten eats fish and kitten is a lovable pet, this is something. The next job is to split them, tokenize them. So, I eat fish and vegetables is something that I create. Then fish are pets, my kitten eats fish are separate words and kitten is a lovable pet. All these things I am converting them to separate words. That is the second step. Then what I am doing? I am picking up each of these things here. So, here we will be calculating TF-IDF. So, the entire document has like this: I eat fish and vegetables. Okay. Then fish are pets. Fish are pets. So, fish is occurring here. So, fish has already been taken into account. Then that is why are pets, this is there. Then my kitten eats and then fish is here again. Then kitten is a lovable pet. So, kitten is again occurring. So, that is why 2 is a lovable pet. Now, here you see that there is pets and pet. So, I should have, before I have done anything, I should have lemmatized it, because that otherwise it is considering pets and pet as to be 2 different words. So, if I consider pets and pet to be 2 different words, then corresponding term frequency, corresponding inverse document frequency will be different. Because if in the same text, if I am saying pet and pets both, then the term frequency should go up, but I am not considering that. If there is 2 different document, where in one document pet is occurring, in another document pets are occurring, if that is happening and I am not considering them to be same word, then the document frequency is coming down, because when I am calculating pet I am not considering pets, when I am calculating pets I am not considering pet. So, 2 different document frequency I am getting, so which is lower than the combined document frequency. So, that kind of problem comes up if you do not lemmatize. So, I should have lemmatized it. Is A, I should have removed them because these are stop words, but I am not doing it because I am just showing you a small example. Fair enough. So, now what I do is I find out for each document what is the document frequency. So, you see that in document 1 I, this is my key, that means document 1 and I. So, this and this basically comes up to be this. You see A5 which is doc 1 and the word num I A7, this is occurring once. This is occurring, this is occurring, this is occurring, this is occurring, but these guys are not occurring. So, in doc 1 these particular words are not there. So, that is why counts are 1, 1, 1, 1, 1, total count is 5. That term frequency for each word is 0.2. Fair enough. The same thing I have done for the next word. So, in document 2 fish are pets. So, fish is occurring. So, document 2 fish is there, document 2 R is there, document 2 pets are there. The total frequency is 3, term frequency is 0.3, 0.33, 0.33. Makes sense? Similarly, third one and fourth one you just check. Here there are 4 words, that is why 0.25. No word is repeating also, you have to understand that. And here there are 4 words again. So, these 5 words, this and these 5. So, I got the term frequencies. So, correspondingly I have written here that doc 1 I, doc 1 eat, doc 1 fish corresponding term frequencies I have written here. Fair enough. Now, how will I find out the inverse document frequency? You have to understand, in the inverse document frequency is, if you remember the formula is log of total number of documents divided by documents where a particular word is occurring. So, here the total number of documents is 4. So, log of 4 divided by count if you count whether the Q7, that means this particular word, is occurring in AY7 to A23. So, AY7 to A23, this is my documents. Here it is how many times it is occurring. So, the occurrences are there and we are taken a log of 2. The base has been taken as 2. Does not matter actually, but in this particular case the log of 2 is something that we are taking, and correspondingly I am getting the inverse document frequencies for each of the word. Just check the formula, and TF-IDF is nothing but the multiplication of these two. So, this is a score to decide that how important a word is. We can put a cutoff and then only create a subset. For example, you can clearly see that there can be certain words which are less important. For example, fish. This is talking about fish only. I eat fish, kitten eat fish, fish are pets. So, fish is the most common word, that is why the IDF is very low, and that is why fish is not something that is important here in this particular text. So, we have to find out which one is important and which one is not important using this TF-IDF analysis. Can we do the same thing for this Sachin is cricketer, Roger plays and Sachin meets Roger. So, let us just do this for this particular word once more. So, if I have to break it, Sachin is cricketer, Roger plays tennis and Sachin meets Roger. Sachin meets Roger. These are the words. So, then what is the list of the word? Basically, Sachin is cricketer, Sachin is cricketer, Roger plays tennis. Now, here Sachin meets Roger, Sachin has already occurred, Roger has already occurred. So, only meets will come. Fair enough. Now, what is the term frequency? This is occurring. So, the term frequency of a word, these are the word list, these are the list of words. I will just copy it and paste it here. These are my list of words. So, then what are the documents? Document 1 has 3 words, document 1, document 1, document 1, then doc 2, doc 2, doc 2, and then doc 3, doc 3, doc 3. If I have these things, these are my word list, these are my document list, this is my word list. So, what is term frequency? The term frequency for this guy is basically 1 by 3. This is also 1 by 3, Roger plays tennis and Sachin meets Roger. So, term frequencies are in all the cases 1 by 3. What is inverse document frequency? So, how many documents are there? How many documents are there? There are 3 documents. 3 divided by log of 3 divided by how many documents? Sachin is occurring in how many documents? 2 documents. So, 2. Then if I just drag it, just tell me that is occurring in how many documents? 1. Cricketer is occurring in how many documents? 1. Roger is occurring in 2 documents. Plays 1. Tennis 1. Sachin 2. Meets 1, Roger and 2. So, then what is TF-IDF? It is nothing but this multiplied by this multiplied by this, and if I just drag them, I got the TF-IDF score. So, I can say here the most important one were tennis or plays or cricketer. So, is should have removed cricketer or meets. So, these are the words which are most common, most important in this particular text. So, that is how we try to find out TF-IDF. So, now going ahead, so we can also use from Wikipedia's plot summary method string search. We can find out that what is the summary of the text. So, Natasha is convinced that she loves Antler and etc. And this kind of text question is that what is the summary of the plot, we can do that. That is where we can also. So, total time is 29 minutes since creation of word cloud, 17 minutes since creation of Pierre, Natasha, Andrew chart, including making this slide for you. So, speed reading with word clouds, what we can do is we can create a quickly as this kind of a word cloud. This says that which are the word which are most common word, most used word. So, we can quickly know that okay, this is there is some prince there, there is also princess, there probably their name is Pierre and Natasha and they said something to each other, their name can be Andrew also, and this is said in the context of Moscow. So, I can clearly quickly tell that what is the context of this particular text. Trending topics, that is also a form of summarization. So, we can see that in which part of the world which kind of topic is more common, usually done in Twitter. So, in Twitter there is the geocode which is also kept in the Twitter tag. So, if you want to know that in which part of the world which text is becoming more common, then I can know that whether the rumor is spreading, why it is spreading, this and that. We can also use this kind of word cloud generator. Word cloud can be generated using your software of interest like R or Python. So, we will be using R. Other than that, there is something called wordclouds.com which you can also use to create word clouds. That is also one option. Then comes another interesting thing called dependency parsing. So, automatic reads dependency parsing is what? It is another method of using natural language processing, where you read the text and automatically understand the dependency. Dependency means what? How one word is dependent on other. So, let us say if I say that I am eating breakfast, who is the subject here? I. What is the object here? Breakfast. What is the verb here? Eating. So, this kind of relationship, who is subject, who is doing the job, what is the job's name and what he is doing with this job, all of these things, the subject, object, predicate, verb can be found out using this dependency parsing. That helps to understand the text. It is not one single text only. In a single text context, the overall context is lost, but in dependency parsing the context is still there. It helps to build generalized rules set after studying sample, and there can be some of the packages in Python, Spassy and Python which is used. In R also we can do that, we will try to do that. So, dependency parsing is like, let us say I want to upgrade my data package. So, you have to understand that what is the verb here. The verb here is want or upgrade. So, key verb is want. Want to what? Who wants? Who is the subject? The subject is I, which is a pronoun. So, the first job is to find out verbs, and then you have to find out that whether one verb is a component verb of another verb. So, I want to upgrade, this is the verb component total, and want is the major verb, and the want what to upgrade, the second verb is upgrade, which is a component verb of the initial verb, and to is just an auxiliary. Then want to upgrade what? Want to upgrade my data package. So, my data package, the package is the noun, data package is actually compound noun. This is what I want to upgrade, and my is a basically a adjective, which is whose data package? My data package. So, this kind of a relationship building, if you can find out this relationship, you know that what this guy is doing, why it is applicable in, let us say, in the text. I want to cancel my flight, they know that okay, want to cancel, want is the major thing, cancel is the, they cancel what? Cancel my flight. Flight means my ticket. Whose ticket? My ticket. So, this kind of answers can be done by dependency parsing. Who is one? I want. If I write my wife wants to upgrade her seat, then who wants? Then he will ask, the automator will ask that can you tell me the passenger name, or can you tell me your wife's name. But if you say that I want to do this, then it will automatically say can you tell me your name. So, these kind of answers can only be given if you understand the dependency parsing properly. So, that is something which also comes under the domain of natural language processing. Another example, I need to change address in records. So, what do you want? What is the major? Need to change. Need is the major verb, change is the adjoining verb, and to is just auxiliary. Who needs to change? I. So, I is my subject. What? Address. The address is my object. Where? In records. So, in records is basically the possible the further things, further details about this particular object that you want to change. So, this kind of information can be done by dependency parsing. Another thing is topic modeling, we will discuss at the right time. Topic modeling is basically from a huge text, if you can find out which part of the text is talking about what kind of words comes together when you are creating topics, that can also be done under natural language processing. So, that is all for this particular video. We will do the term frequency, inverse document frequency and word clouds in the next video. Then we will do something on spam detection in the next video. In the next week, early next week, we will do topic modeling also and dependency parsing also. So, let us see how it goes. Thank you for being with me. I will meet you in the next video. Thanks.